A $500 United States jamming device can render a $1 million robotic combat platform completely defenseless in a split second. This is the terrifying electronic reality facing China as the People's Liberation Army prepares for intelligentized warfare. Leading global defense analysts argue that the strategic deployment of the China NORINCO VU-T10 heavy unmanned ground vehicle has reached a critical tipping point. On paper, their only tactical salvation would be an absolute reliance on advanced onboard artificial intelligence, because traditional remote-controlled data links are instantly severed in high-intensity combat. In early 2026, newly released military field evaluation reports confirmed that the 11-ton VU-T10 was subjected to maximum capacity electromagnetic interference during simulated urban assault drills. If the primary command frequency is blocked, these expensive mechanized assets are exposed to total isolation and become tactically useless on the modern battlefield. As global military powers deploy intelligent jamming nets that can blind any unmanned asset, can this autonomous machine survive the electronic death zone? Or are frontline planners forced to accept that human crews must return to the trenches? The stakes have never been higher for the future of robotic armor. Before we go on, do you think artificial intelligence will completely replace humans on the battlefield? Or is it just an expensive gamble? Subscribe to the channel now to follow this defense analysis, and tell me where you're watching from. To fully grasp the vulnerability of heavy, unmanned ground vehicles, one must look at the hard operational data from recent global conflicts. During urban combat deployments between 2022 and 2024, early-generation Russian unmanned platforms like the Uran-9 experienced catastrophic command link failures. Military field records indicate that the Uran-9 lost connection with its base station 17 times in a single deployment, with one major instance leaving the 12-ton vehicle completely unguided for 90 minutes. This happens because ground-based radio waves suffer from severe signal degradation caused by buildings, ruins, and terrain, which is 10 times worse than the line-of-sight conditions enjoyed by airborne drones. When an adversary deploys intelligent jamming systems, the heavy VU-T10 faces an identical physical barrier. This presents a massive financial risk for the People's Liberation Army. A single VU-T10 platform equipped with a 30mm automatic cannon and dual HJ-12 anti-tank missile launchers costs an estimated $2 million United States to manufacture. Pitting such an expensive machine against a high-density electronic warfare network that costs a fraction of that amount creates an unsustainable economic deficit. Furthermore, the physical limitations of its sensory suite present a major tactical flaw. To navigate independently, the VU-T10 relies heavily on an active LiDAR 3D laser scanning system alongside electro-optical cameras. Defense tech evaluations show that, in a chaotic combat environment, heavy smoke screens, burning debris, and thick coastal fog will scatter the laser pulses. This physical limitation effectively blinds the onboard computer before the vehicle can even engage a target. For any military planner, relying on a multi-million-dollar platform that can be rendered blind and deaf by basic atmospheric interference and cheap electronic jamming is a dangerous tactical gamble that cannot be ignored. To counter these severe physical and electronic limitations, China is actively pursuing algorithmic warfare through a method known as autonomous edge computing. When the VU-T10 detects high-intensity electronic warfare jamming, it immediately terminates its vulnerable remote data link. By cutting off all external communication, the platform becomes entirely immune to radio frequency jamming and cyber takeovers. In this independent state, the onboard artificial intelligence processing unit takes absolute control of the 11-ton vehicle. Using a preloaded database and real-time data fusion, the system calculates its own path and identifies threats without relying on global positioning system networks. This transition was successfully demonstrated in early 2026, when several VU-T10 units maintained operational autonomy during maximum capacity electromagnetic suppression drills. Beyond its advanced digital brain, the physical capabilities of the platform provide a highly potent solution. The VU-T10 features a dual propulsion hybrid diesel-electric system that allows it to switch into a silent electric mode. Traveling at speeds up to 60 kilometers per hour, the vehicle suppresses its acoustic signature and reduces its thermal radiation by 90%. Allowing it to bypass enemy thermal sensors in complete darkness. For firepower, the automated turret houses a 30mm automatic cannon capable of firing 300 rounds per minute, integrated alongside two HJ-12 top attack anti-tank missile launchers. Strategic Defense reports for late 2026 project that the People's Liberation Army will deploy these unmanned assets as a first-wave expendable force. In a regional island invasion or coastal landing scenario, a vanguard of autonomous VU-T10 units would advance to detonate minefields, absorb initial anti-tank fire, and neutralize defensive bunkers. This strategy directly alters the balance of power in the Indo Pacific, by ensuring that the initial heavy attrition of frontline combat is entirely sustained by silicon and steel rather than human personnel. This tactical evolution highlights a profound philosophical clash between two distinct military doctrines shaping the year 2026. On one side, Western strategic planners focus heavily on a mass and cheap doctrine, utilizing tens of thousands of low-cost first-person view drones combined with dense electronic warfare networks to achieve battlefield dominance through attrition. On the other side, the Chinese People's Liberation Army and NORINCO are investing millions of dollars into a heavy and autonomous doctrine, betting on sophisticated, self-contained 11-ton platforms that do not rely on external communication to accomplish their mission. The integration of the VU-T10 heavily weaponized platform represents a deep shift away from human-centered warfare toward algorithmic combat. The ultimate lesson of this electronic arms race is that warfare is no longer just a measure of industrial capacity or physical armor thickness, but a competition of software speed and edge computing endurance. However, this transition leaves global defense experts with an unresolved ethical and operational dilemma. If a heavy unmanned asset is completely cut off from human command and relies solely on an automated internal loop to differentiate between a combatant holding an anti-tank weapon and a civilian holding a tool, the margin for catastrophic algorithmic error becomes dangerously high. As autonomous armored units continue to mature, the global community must confront the reality of machines making final tactical decisions on the battlefield. If full-scale conflict erupts tomorrow, would you place your trust in a dense electronic warfare shield to blind the enemy? Or do you believe that independent artificial intelligence armor like the VU-T10 will inevitably crush all conventional defenses? Share your thoughts and technical perspectives in the comment section below. Thank you for watching, and make sure to like and subscribe to remain updated on the future of global military technology.